So I'm going to show you how to do a molecular equation, a complete ionic, and net ionic equation for a reaction. The reaction that we are going to look at is a piece of potassium is added to a solution of calcium chloride. So you should recognize that potassium is an element. Calcium chloride is a compound. And so when you have an element plus compound, that is a single replacement reaction. Single replacement. So the first step is to write the molecular equation. In the molecular equation, we need to write all of the chemicals that are reacting. I'm going to check the charges for calcium and for fluoride to write the correct formula for calcium fluoride. And then I'm going to predict the products. So since this is single replacement, potassium is going to replace calcium, kick calcium out. So now potassium is going to be with fluoride. Potassium is +1, fluoride is -1, so it's a 1-to-1 ratio there. And calcium will be by itself. So that's the beginning. Now I have my reaction written. I need to write the states of matter for each chemical and make sure that it is a balanced equation. So in order to balance it, I put a 2 here because there are 2 fluorines. So the 2 goes to the K and to the fluorine. And because I put that 2 here, I now also need a 2 on front of the K. Alright, so this is balanced. Now I need to write the states. Well, a piece of potassium. Potassium is a metal. A piece of it would be a piece of solid. It's added to a solution of calcium fluoride. The word solution is your clue that calcium fluoride is aqueous. And then the fact that you know that any group 1 metal in a compound makes that compound aqueous tells you that potassium fluoride is aqueous. And then calcium, when it's all by itself, again, that's another solid because it is a metal. So that is my molecular equation. From there, I am going to move to my complete ionic equation. In order to do that, anything that is aqueous needs to be split apart into its ions, into charges. Anything that is solid, liquid, or gas is going to be rewritten exactly as it was before. So because potassium is a solid, I'm going to leave it alone. No charges written on it. Solids, liquid, gases, no charges. It is only the aqueous compounds that get split apart into their ions. So calcium is a +2, aqueous, plus we have to take our fluoride ion. Now notice this 2 right here. That's telling you you have 2 fluorides. So we're going to write that 2 in front of the fluoride ion, put its charge, and label that it's aqueous. And then again, potassium fluoride is aqueous, so we need to split that up into ions. The coefficient 2 goes to the potassium and the fluoride. And then I'm running out of room, so I'm going to write the calcium down below. It is a solid, so it does not get any charges. So that is the complete ionic equation. Anything that is aqueous gets split apart into charged ions. Anything that is solid, liquid, or gas stays exactly the same as the molecular equation. Make sure that you continue to bring the balancing coefficients down every single step. To go from complete ionic to net ionic, you have to cross out spectator ions. So those are ions that stay aqueous on both the reactant side and the product side. And in this one, it is only calcium. I take that back. It's only fluorine. Sorry. Can't read my own writing. So only fluorine is aqueous here and aqueous over there. Everything else will have to stay for the net ionic. So the net ionic is that solid potassium reacts with the calcium ion, and you get the potassium ion, which is aqueous, plus the calcium solid.